Hello students, welcome to 60 out of 60 in KCET Chemistry 2025 series in just 200 days. So as you all know, we have started the organic chemistry, and in today's class we are going to understand about nomenclature. Okay, so you want to join our WhatsApp channel, the link is there in the description section. Please go there and join the WhatsApp channel. This will help you to get access to our PDF notes and other important details. Okay, so nomenclature is one of the very important topic from where you can get questions in your KCET exam as well. Okay, so that definitely this is what you need to master. So please watch this complete video, and at the end I'll be giving you some homework questions also. You need to do that and submit your answers in the comment section. Okay, so now let's get started. So today part 2 we are going to do nomenclature, then we are going to discuss all these things. Okay, so weightage, you can see from this chapter particular directly questions are not asked, but yes, this chapter is very important to understand all the organic chapters of PU2. If your fundamentals are not clear here, then you will definitely face difficulty in the PU2 chapters, right? So that is why please follow this organic chemistry series and make sure that you practice all these questions and you master these concepts well. Okay. So now here I want to announce regarding the PU2 success blueprint test series. So if you are an aspirant of PU2 and want to get 95% and above, then this test series is for you. In this test series you have 12 mock tests, which includes 4 part tests and 8 full length papers. The question papers are according to the latest pattern and syllabus. Apart from the question papers, you will also be getting the video solutions with detailed explanation, doubt clarification classes and one shot revision videos. Okay, so definitely if you want to get 95% and above, please avail this opportunity and buy this test series at a discounted price of 599 rupees only, because later you know the prices may go high. So make sure that you purchase it right now. The link is there in the description section. Please go there and purchase this test series and make sure and just boost your preparation for PU2. Okay, fine. So now coming to nomenclature. So nomenclature we will be studying under these categories. So first is nomenclature of alkanes. Okay, then nomenclature of cyclic compounds, nomenclature of functional groups and nomenclature of substituted benzenes. Okay, so now before coming to nomenclature, I want to tell you something about the hydrocarbons. Okay, so carbon compounds can be of 3 types basically. You have alkanes, okay, you have alkenes, okay, and you have alkynes. Okay, now alkanes means if the carbon between 2 carbon there is only single bond between 2 carbons, then those type of compounds are called as alkanes. If in the compound there is 2 bonds between carbon, then it is alkene, and if we have 3 bond, then it is alkynes. Okay, so alkanes general formula is CnH2n plus 2. Okay, so you can easily identify. For example, if it is C7H16, right? So this is 2n, 7 2s are 14 plus 2 16. Then if this is the formula, then I can easily say that it is an alkane group. Okay, similarly if you have CnH2n, then we will call it alkene group. Okay, for example C5H10. Okay, now alkynes. Okay, alkynes means what? We have CnH2n minus 2. Okay, so for example I have C5 and H8, right? 5 2s are 10 minus 2. So these are the type of compounds of hydrocarbons are present of alkanes, alkenes and alkynes. Okay, now let us go to the nomenclature of alkanes. So there are certain rules that we need to discuss first, and based on the rules we will do examples. First thing, step number 1, identify the longest carbon chain. Okay, or you have to identify the parent chain. Now find the longest continuous chain of carbon atoms. This forms the base name of the compound. Example, methane, ethane, etc. Okay, so you have to find the longest continuous carbon chain. Okay, now in the longest continuous carbon chain, if there are 2 carbons, then the word root we use, or the word that has to be used, is eth. If 3 carbons, prop. Okay, 4 carbons, but. 6 carbons, hex. Okay, I left 5. So 5 carbons, pent, 7 carbons hept, okay, 8 carbons oct, 9 carbons non, 10 carbons dec. Okay, these are the word root. So first you have to find how many carbons are there. The longest carbon chain is the thing that you need to identify first. Okay, next is what? Number the chain. You have to give numbers to the chain. Like carbon you have identified, suppose 7 carbons are there, you have to number them 1, 2, 3, 4, 5, 6, 7 like that. But what are the rules that you should follow while numbering? The substituents, what do you mean by substituents? The side groups, okay, get the lowest number possible. Okay, now suppose I have a carbon like the chain like this, okay, and here is a substituent, right? So what is the longest carbon chain? The longest carbon chain is of 5 carbons. Right, now on the second carbon I have a substituent here. Okay, now I can number it in this way, 1, 2, 3, 4 and 5. I can also number it in this way, right? Then which numbering is correct? According to the second rule says that this rule is correct. Why? Because in this rule or in this particular chain, if you see 5 carbons are there, in this particular second carbon is having the substituent. So the carbon which, if you number in this way, the carbon which contains the substituent should get the lowest number. But if you number in this way, this is the carbon which is containing the substituent, its number is 4, right? But if you number in this way, the carbon which contains the substituent, its number is 2. Right, so that is why this is the correct way of numbering, in which the carbon containing the substituent should get the least number. Okay, clear? Next, if there is a tie, prioritize the functional group with higher precedence. So this one I'll give you example. Okay, for example, you have a like this. Okay, here you have OH functional group and here you have double ketone functional group. Now if you see, this is also getting 2, this is also getting 2, right? Then the correct way is the one in which the higher functional group gets the lowest number. So if we see the, I'll tell you the functional group order also. Ketone is the higher, I can say it is a higher prior functional group, means it has more priority, so it should get the lowest number. So you should number in this way. Okay, functional group we will discuss in detail ahead also. Clear? First step is to identify the chain, longest carbon chain. Second step is to identify and number the chain correctly in such a way that the substituent should get the least number. Okay, now third step is identify and name the substituents. The substituents are the side groups attached to the parent chain. Use prefixes like methyl, ethyl, propyl for the substituent. Okay, if the same substituent appears multiple times, use prefixes like di, tri or tetra. Okay, so step number 1 to identify the longest carbon chain. Step number 2 to number the chain. Step number 3 is to identify the substituents that is present. Next, arrange the substituents alphabetically order. So write the substituents name in the alphabetical order. Ignore di, tri, etc. for the alphabetical order. Now example, ethyl comes before methyl. Okay, suppose you have a 4, or I can write 5 carbon. Here you have, for example, methyl group, okay, and here you have ethyl group. Right, I told you ethyl means 3 carbon. So if I want to number it, okay, the numbering should be like this. Okay, now if you see that on this carbon, this is ethyl group, so this has to be named first, okay, because it's alphabetically ordered, this is coming first. Okay, E. Next, add functional group suffixes. So functional group determines the suffix of the compound. If it is a pure alkane, the name will end with ane. So prop, N. Okay, if it is a double bond, propene. If it is a triple bond, propyne. Okay, OL, alcohol group, OH group is attached, then propanol. If CHO group is attached, propanol. If ketone group is attached, propanone. If acid is present, propanoic acid. These are the substituents that we generally use in the questions. Okay, next, assign priority to the functional groups. If multiple functional groups are present, follow the priority for suffixes. So carboxylic acid is more priority than aldehyde, then ketone, then alcohol, then alkene, then alkynes, and lastly we have alkanes. Okay, so for this, for example, if OH, if your carboxylic acid is also present and alcohol is also present, okay, then the main name should end with carboxylic acid and this one will behave as a substituent. So for that we have to use the word hydroxy. If ketone is a substituent, then you have to use oxo, okay, for lower priority groups. Next, double and triple bonds indicate the position of double and triple bonds in the chain using the lowest possible numbers. So for example, but2ene is there, so you should number, if the double bond and triple bond is present, number should also be assigned to them. Okay, fine. Next, you have to combine the name. So this is what you should remember. So students, many of you might not be understanding many of the points, but please do not worry. Examples, I will explain each and every example with the steps that I have discussed with you. Okay, so now you see what should be the name written order. The prefix part, okay, should be about the substituents. Okay, you should write the substituents first, and the substituents should be in the alphabetical order with their positions. Okay, so substituents alphabetically with positions, means on which carbon they are attached. Okay, then you have to write the root name. Root name should be based on the parent chain, and parent chain depends on the longest carbon chain. Okay, next, the suffix part. Okay, suffix part is based on the highest priority functional group. So whichever, so in the compound, whichever functional group is there which is of highest priority, based on that the suffix should be there. Okay, so for example, we have this compound like this, this one, right? So you can see here, I will name them. There are 5 carbons in the main chain, so and the substituent should get the lowest number, so I will name it like this, right? And then first I will write the substituent and its position. It is on the second carbon, so 2-methyl. Okay, then you write the parent name. 5 carbons are there, so it is pent. Okay, and now you see this is a simple alkane, so the suffix should be ane. Okay, fine. Now let us do some examples. This question is there. Okay, so first thing is to identify the longest carbon chain. So if you see, I can find a carbon chain like this, 1, 2, 3. Like continuously there are 3 carbons, and there are only 3 carbons in this particular chain. So this is not the longest. What I can find, 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5. Okay, or 1, 2, 3, 4, 5. Okay, so there are different possibilities here, but all are of 5 carbon chain, so you can take any one. Okay, so I'll write like this, 1, 2, 3, 4 and 5. Okay, identified the longest carbon chain. The second thing is to number them, 1, 2, 3, 4, 5. If I number from this side also, it will come same only, 1, 2, 3, 4, 5, and on the second and fourth position you will get methyl groups. So here whether you number from this side or from the other side, it is same, right? Now what we have to do? Second thing is, third step is to identify the substituents. Here only 1 carbon substituents are there, so this is methyl group. But you see, it is the 2 times methyl is present, right? So you have to use the word di, di, di. Okay, and on which positions it is present? 2 and 4 positions. So how I can write the name? See, so I got the substituents. I told you first it should be substituents, then parent name, then the suffix. So the prefix part will be 2, 4. Okay, at this position 2 and 4 dimethyl. Okay, if these substituents are different groups, then you should write 2-methyl, 4-ethyl, something based on the alphabetical order. But because the 2 substituents are same, so 2,4-dimethyl pent. Okay, 2,4-dimethyl pent and ane. Alkane group, it should end with ane. Okay, clear? Next, let us see the next question. So this question I have already numbered for you. Okay, 1, 2, 3, 4, 5, 6, 7. Okay, 7 carbon chains are there. Now you see, on the 4th carbon you have 2 substituents, and on the 3rd carbon you have 1 substituent, right? Now the 3rd carbon substituent name is ethyl, 4th carbon substituent is methyl. So which one will come first? The ethyl will come first based on the based on the alphabetical order, right? So what I will get? 3-ethyl. Okay, next, on the 4th position we have 2 substituents, right? So we should write 4 times, 4 I have to write 2 times, that means see, 4, 4, okay, dimethyl. Okay, 3-ethyl, 4, 4 dimethyl. This is clear? 3-ethyl, 4, 4 dimethyl. Okay, you have written all the substituents. Now why this di is coming? Because we have 2 methyl groups, and when you write di you have to mention the position 2 times. So this all part comes under the prefix. Okay, next you have to write the parent name. So there are 7 carbons, so the parent name will be hept. Okay, and next you see there is no double bond, nothing, simple alkane, so this is suffix, right? So this is the word root and this part is the suffix. Clear? Okay, let us do another example here. You have to first find the longest carbon chain. So if I see like this, 1 2 3 4 5 6 7 8, right? 1 2 3 4 5 6 7 8. So I can number it in any way. So 1 2 3 4 5 6 7 and 8. Now a question may arise that the substituents are present on 3 and 6, right? On third we have ethyl group and on sixth we have methyl group. Then why can't we number in this way? 1 2 3 4 5 6 7 and 8, right? Here a confusion arises. This side also if I do 3 and 6 I am getting, this side also if I do 3 and 6 I am getting, then which is the correct one? So if this type of confusion arises, then the rule here you should follow is, you should, if you see methyl and ethyl, which is alphabetically, which one will come first? Ethyl will come first, alphabetical order. So ethyl group should get the least number. Okay, ethyl will come alphabetically order. Ethyl will come first because it is starting with E. So the carbon containing the E should get the least number, right? So so that is why I can say that the correct order of numbering is this one. Okay, because here ethyl is getting least number. If I number from this one, methyl will get 3 and carbon containing ethyl group will get 6, which is not correct according to this rule, right? So now let us write down. So ethyl, because it is substituent, its name should be 3-ethyl, and on the sixth group we have methyl. Okay, so this part is what? Prefix. Substituents we have written with their positions. Next we will write the word root. There are 8 carbons, so the word root is oct. Okay, now because there is single bond only, so it has to be end with ane. Okay, this is suffix. Clear? Prefix, root and suffix. Okay, let us see next question here. So one second, let me erase this part. We will write the name only. I hope all of you have understood what I was saying here. So that is, name is 3,3, okay, dimethyl, 3-ethyl 4,4-dimethyl, right? 3-ethyl 4,4-dimethyl heptane. Clear? Now let us see the next one. Okay, so here if you see the longest carbon chain, I have already marked 1 2 3 4 5 6 7 8 9 10. Okay, so you can see on the third carbon we have 2 substituents, and on the fifth carbon I have one big substituent, right? And this substituent is again a branched one. Okay, this is again a substituent is having another substituent, right? So you can see this is the chain, and here we have substituent. This whole is a substituent. Okay, in this substituent there is another substituent attached, and that means this is substituent of substituent. Okay, then how can you name it? Fine. So first we will start like this. See, definitely this is starting with what? Propyl, the 1 2 3 4, sorry, butyl group. Okay, so now you can see the 1 2 3 4. So we have on the second carbon we have ethyl group. Okay, so the name of this substituent is what? See, 2-ethyl, okay, 2-ethyl butyl. Okay, this is the name of this substituent, means on the second carbon ethyl group is present and the whole group is butyl, but this part is attached to which carbon? Fifth carbon. So how we should name it? So it should be like 5. Okay, on the fifth carbon we have what? 2-ethyl butyl. Okay, this is present on the fifth carbon. Now because it is starting with ethyl, it has to be written first. Then on the third carbon we have another 2 methyl group, so 3,3-dimethyl. Okay, 3,3-dimethyl, total number of carbons is 10, so decane. Okay, 5 2-ethyl butyl 3,3-dimethyl decane. Clear? Okay, now let us go to more examples of branched alkanes. Okay, so you can see here this group is like this. One second, sorry. Okay, so this, let us expand and draw it once again. Okay, so it is like CH3. Okay, then you have one more CH2, then you have one more CH2, then you have CH. Okay, then CH3, CH3H. Okay, next you have the fifth carbon here, which is having CH, and you have CH3, CH, CH2, CH3. Okay, now after that you have CH2, 6, 7, 8, 9. Okay, so you have 6, 7, 8, 9 and CH3. Okay, this is the structure, right? Now if you see, you have to number it, right? Now this group, okay, now you can see this is a chain attached to this one, so you can write it as 1, 2. So 1 methyl ethyl. Okay, this is 1 methyl ethyl, and this one you can write down as 1 methyl propyl, right? This is 1 methyl propyl, this is 1 methyl ethyl. Okay, now you see the name here, 1 methyl ethyl, here 1 methyl propyl. This one will come first, right, according to the alphabetical order. So that is why you have to name it in such a way, right? So I'll get 1, 2, 3, 4. If you name from that side, then you will get higher numbers, right? 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So on the fourth carbon, what I have? 4. Okay, fourth, this one. Then I have here 1 methyl, or you can simply write methyl ethyl. Okay, because it is in the one position, you do not have to mention here. So 4 methyl ethyl. Then fifth one, what I'll do? Ethyl propyl. So then I'll write fifth ethyl propyl. Methyl propyl. Yeah. Okay. 5 on the fifth carbon we have methyl propyl. Then decane. Decane. Okay. So this part is substituent. This is the word root and this is the suffix. Okay. Here one more question is there. This is simple. You can, I think you all can do this. So this example you can try in your book now. Okay, and comment down the answers. I'll be giving you the answer in the last for this question. Okay, fine. Next, let us go for cyclic compounds. So if you can see, there is for cyclic compounds you have to add a word cyclo before the name. Okay, so this is 5 carbon. Okay, so 5 carbon means it has to be pentane, but we will write cyclopentane. Okay, next, if you see this one, numbering should be in such a way that you will get least number. Okay, so 1 and 3 substituents are there, and here this is propyl group, this is methyl group, alphabetically order you have to follow. So you have 1 ethyl, okay, then 3 propyl, this is 6 carbon, so cyclohexane. Okay, next if you see this one, okay, next here you can see you have on the first carbon 2 substituents and on the third carbon 3 like propyl group. Okay, again based on the alphabetical order, but here you can find 2 substituents. 2 substituents means 1 1, right, dimethyl, 1 1 dimethyl, then you have 3 propyl cyclohexane. Okay, 1 1 dimethyl, 3 propyl cyclohexane. Okay, next we'll go for functional groups. Okay, so you have to remember certain functional groups that are there. For alkanes we already know it is A and E, for alkenes E and E, for alkynes Y and E. Okay, now for halides you have to use halo, like for example there is a bromine group attached, and if you see there are total 4 carbons, so 1 bromobutane, 1 chlorobutane, 1 fluorobutane, like that you can use. For alcohols the ending will be with, alcohols is symbolized by OH, it will end with OL. Okay, next aldehydes will end with AL. Okay, next ketone will end with ONE. Okay, suppose for example it is like this, CH3, C double bond O, CH2, CH3, right? So 1, 2, 3, 4, right? This is the functional group, right? So how many carbons are in functional group? The functional group should always be written in the suffix part, right? So there is no substituents here, so we will write the parent name butane, right? Parent name is butane. Then 2 on the second position we have the suffix or the functional group. ONE represents that it is a ketone functional group. Okay. Similarly for amides, sorry, for nitriles we use the word nitrile. Okay. So for example, if you have pentane nitrile, okay, then the compound is like this, suppose 1, 2, 3, 4, 5 and CN, right? So 1, 2, 3, 4 and 5. On the first carbon we have this one, so you can write pentane 1 nitrile. Clear? Next we have similarly ethers, carboxylic acid, carboxylate ions, esters, acyl halides, amines, amides, nitro compounds and sulfonic groups. Okay. So for ethers we use the word alkoxy-alkane. Okay. Similarly for carboxylic acid, oic acid. The substituent is oic acid. Very simple. Then for esters, for esters you use alkyl alkanoate. For ethers it is alkoxy-alkane. For esters it is alkyl alkanoate. Okay. Next, acyl halides, generally questions are not asked. Amines you use amine only as a substituent, sorry, as a suffix. For nitro compounds you use nitro in the before. Okay. Nitro is not used as a suffix, it is used as a prefix. Then sulfonic compounds is also used as a suffix. Okay. We'll do examples, then it will be clear. So next, coming to benzene. Okay. So here just you have to write the name of the substituent and benzene. Okay. So methyl is present, so methyl benzene, it is common name is toluene. This is very important, you should remember. Then this one is methoxy group, so methoxybenzene. Okay. Its common name is anisole. If NH2 is present, then we call it aminobenzene or aniline. This is also common name is more popular. NO2 simple nitrobenzene, Br simple bromobenzene. Okay. Fine. Next, let us do this question now. You have to write the name of this compound. Okay. Now you should number it in such a way that the total addition of the substituent should be a least number. Now see, suppose I number it in this way: 1, 2, 3, 4, 5 and 6. So what is the addition of the substituents? I'll get 1 plus 2 plus 4. Right. So that is 7 I will get, right? 1 plus 2 plus 4. Now if I number it in this way, like I'll take this one 1, this one 2, this one 3, this one 4, this one 5, this one 6. Then what is my addition of substituents? You can see 1, there is one substituent, then 4 I have, and then 6 I have. So that is 11. So this is wrong. Any other we can try? We can try from the nitro group, right? So if I give it like this, 1, I'll take another color. Okay. So 1 is this carbon, this is 2, this is 3, this is 4, this is 5, this is 6. So what I'll get on 1 I have, then on 3 I have, right? Then I have on 1, 3 and 4, right? 1, 3 and 4. So that is total equal to 8, right? So you have to always select the lowest one. Okay. So that is why this is the correct one, this is wrong, this is wrong, because addition is coming here higher, right? So which one is the correct one? The red one. So I will erase all other things. 1 second. Okay. So now what will be the name? Once we are done with the numbering, or once we have given the number, you have to just write the substituents and the parent name. Okay. So I can write here, that is 2 and 4 nitro group is there, and on 1 chloro group is there. Alphabetical order, chloro will come first. So it will be 1 chloro, okay, then 2,4 dinitro, benzene, okay, 1 chloro, 2,4 dinitro, benzene. Clear? Okay. Next, if I have this one, here also substituent rule you should follow. So 1, 2, 3, 4. So I know this one will be the lowest one, because here adjacent you are using, or you can use it like 1, 2, 3, 4. That is also correct. So let us see. 1, we'll use a different color. Okay, 1 second. Yeah, so if I use like 1, this is 1, this is 2, this is 3, and this is 4. So here also substituents are like 1, 3 and 4, that is 8, and here also it is 1, 3 and 4, that is 8. But which one you should follow? So you should check that the alphabetical order which is coming first should get the lowest number. Okay, so first is chloro. So whether if you are numbering from this side, chloro is getting 3, if you number from this side, chloro is getting 2, right? So that is why chloro should. So now you see that chloro, if you number from this side, right, chloro is getting the least number, right? So that is why chloro should be like this, should be the order of naming or order of numbering. So then what I will get? 1 methyl. Okay, 1 methyl, then I will have 2 chloro, okay, 1 methyl, 2 chloro and 4 nitro benzene. Okay, fine. Next, you can see this example. Here I have also already done the numbering, you can see. Now see, since again chlorine is the one which is having least number, right? But OMe group is a main functional group. So this name, if OMe is present, then we call it anisole, right? So that means this one should be given 1, 2, 3, 4. So I have here 2 chloro, right? I can write 2 chloro, then 4 methyl. Okay, this is not a substituent, it is a name of the parent chain only. You can write anisole. Okay. Next, if you see this one, here also you can see this, if NH2 group is present, then we call it aniline, right? So we can write same way, 4 ethyl, then 2 methyl. So I have 4 ethyl, okay, 2 methyl, okay, 4 ethyl, 2 methyl. What is the name of this one? Aniline. Okay, so if NH2, OCH3 or OH is present, then that functional group should be given the number 1. Then you should write whether to go left hand side or right hand side based on the substituents present. Okay, now one more example if I show you. Here OH is present, phenol group. So definitely you can see 1 should be given here, then 3 and 4. So both are methyl group. So I can write 3,4 dimethyl. Okay, 3,4 dimethyl phenol. Okay, done, fine. Next we'll go for solving the hybridization. Okay, so here you should remember that carbon has 4 bonds. Okay, if carbon has 4 single bonds, okay, then the hybridization is sp3. If carbon has 3 single bonds, sorry, means carbon has yeah, 1 second. If carbon has 2 single bonds only, okay, 2 single bonds, okay, then it is sp2 hybridization. If it has only 1 single bond, then we call it sp hybridization. Okay, so in this what you have to do, check each of the carbon and tell its hybridization. Okay, so I will write this one, 1 second. I'll write it at the top so that we can solve the question here. Okay, so see, if carbon is like this, okay, then it is sp3 hybridization. If it has structure like this, then it is sp2 because it has 3 sigma bonds, right? Then it is sp2. And if it has structure like this, okay, 2 sigma bonds, then it is sp hybridization. Now let us do this one. First one, CH2. Okay, I am expanding the structure, double bond C, double bond O. Okay, now if you see for first carbon, okay, here we have 1 sigma, 1 sigma, 1 sigma, total 3 sigma, then we will call this carbon is sp2 hybridized. Okay, this one is sp2. Now this carbon, if you see 2 sigma bonds are there, 2 sigma bonds means it is sp. Okay, next one, if you see CH3, okay, then you have CH, double bond CH2. Okay, so here if you see this carbon is having 4 sigma bonds, right? 4 sigma bonds means the first carbon is sp3 hybridized. Okay, next carbon if you see 1, 2, 3 sigma bonds, so it is sp2 hybridized. Next if you see this carbon, this has also 3 sigma bonds, so it is also sp2 hybridized. Okay, next third one, if I see CH3, C double bond O, CH3. Okay, so the first carbon, if you see, it has 4 sigma bonds, so it is sp3. Okay, next if you have 3 sigma bonds, then it is sp2. Okay, and then again if you have 4 sigma bonds, it is sp3. Next structure, if I see, it is CH2. Okay, double bond CH. Okay, then C triple bond N. Okay, now 1 2 3. So if we have first 3 sigma bond, then it is sp2 hybridized. Okay, next if you have 3 sigma bonds, again it is sp2. Now you see this carbon has only 2 sigma bonds, right? This one and this one, 2 sigma bonds, means it is sp hybridization. Now last one, C6H6 structure, all of you should remember, it is a benzene ring. Okay, so each carbon, if you can see 1 2 and there is one H here, each carbon is having 3 sigma bonds, so each of these carbon is sp2 hybridized. All the 6 carbons are sp2 hybridized. Okay, fine. So this is some homework question, so you have to write the name of these compounds. I'll be discussing the answer in the next class. Okay, so make sure that you understand the rules once again, do all the examples of your NCERT book and try these questions after that. Okay, so yes students, once again I want to remind you about the PU2 success blueprint test series. So if you want to get 95% and above, then this test series is for you. It is available at a discounted price of 599 rupees only now. Later on the prices will definitely increase, so that is why please make sure that you buy it as soon as possible. The link is there in the description section. Please go there and purchase the test series and boost your preparation. Okay, all other details I have already told you. You'll be getting the subjects PCMB and CS. Okay, and doubt clarification classes, one shot revision videos and detailed video solutions also you will be getting. Okay, 12 mock tests will be there, so every Sunday there will be a test, so make sure that you avail this opportunity as soon as possible. Okay, fine. That's all in this class students. I hope nomenclature is clear to you now. In the next class we are going to discuss another very important topic, that is isomerism. Okay, so make sure that you follow this series and clear and master all your fundamentals of organic chemistry. Okay, so do not forget to subscribe the channel and see you soon in the next class.